So let's take a look at our conclusions from our lab activity yesterday and then apply those to a situation on the Earth in reality. First of all, let's look at the lab results. Your numbers are going to be different than mine, so I'm just going to use some examples. The starting temperature was pretty chilly. Might have been about 47 degrees or so because we were using ice water in the bucket. But the water on both sides should have been the same temperature to start, or very similar. When you turned on the lamp, well, then the temperatures became different. On the lamp side, the sunny side, and I'm just going to use an example, let's say it went up to 67, which would be a temperature change of about 20 degrees. It got a lot hotter because it was getting a lot of sunlight. Sunlight's like energy from the sun. It's going to raise your temperature. Now, on the dark side, there was no light. So we would not think that the temperature on the dark side would go up if it's not getting any energy, but it actually did. It might have gone up to something maybe 50. And once again, these are just examples. So that would be a temperature change of 3. So both sides had their temperatures go up, even though only one side was getting energy from the lamp. And we know it's the energy that makes things temperatures change. So we're going to explain here and now what happened. How did the dark side get hotter even though it didn't get any light? So here was our setup. And we've got energy going into the water over here. And the water particles move faster and they're moving around more and they cause more friction and the temperature goes higher. And we know that if you put something under a light and it gets more energy, the temperature is going to go up. What we need to explain is this situation over here. What happened on that side? Because it didn't get any light. So why did its temperature go up if it wasn't getting energy? All of the energy was over here. Well, here's what happens. The water on this side over here gets hot and it moves a little bit more. So it starts to move over there and it mixes with the water on that side. Well, if you have something hot and you mix it with something cold, you know the cold is going to get a little bit warmer. And that's what was happening here. We had water from this side, the lamp side, taking energy over here to the dark side. Now that's one of our definitions that we have about temperatures. When water takes heat from one place, takes energy from one place, and transports it somewhere else, and then gives it to somebody else, that's called convection. And that was the first, one of the first key terms here. So first of all, let's describe here. These are the three things that describe 3 steps. How did the temperature of the shady side change even though it was not receiving any light? First of all, the water under the lamp gained energy from the light. First step. That water expanded. It got bigger. It moved more. It moved away from that side. So the second step is the hot water expanded and it moved to the shady side or the dark side of the pan. 3, when hot water mixes with cold water, it's going to make it warmer. So this is why the the water on the dark side got warmer even though it did not get any light. It didn't get any new energy. It's kind of the three-step process. This is an example of heat transfer by the process of convection. Convection is when water, or it can be air, transports energy from one place to another. Now let's take a look at this here. This is the Earth, and this is in winter time. And you'll notice the places up here are getting no sunlight. That's that example of a polar night. You never see the sun. It stays dark all day and all night. You have nighttime for 24 hours. So, a place like Barrow, Alaska, and any other place above this line called the Arctic Circle. All these places up here get no sunlight in the winter. For most of the winter, like 82 or 83 days, they get no sunlight in Barrow, Alaska. This is what noon looks like in wintertime in Barrow, Alaska. They get no sun at all. It stays dark all day and all night. Now, what do you think their temperatures are like up here if they don't get any sunlight? Well, if you don't get any sunlight, you would think you're not getting energy. You're going to be really, really, really cold. And that's what we would expect with Barrow, Alaska. It should be impossibly cold, like too cold to even live there. Because if you don't get any sunlight, how can you have any kind of temperature? But that's not the case. People in Barrow, Alaska do live there, and it actually isn't as cold as you would think, even when they don't get any of the sunlight. And here's why. This is the same as what we saw in the lab. This is the equator. This is like our lamp side in the lab. That's where all of the sunlight is hitting the Earth at the equator. So this area gets hot. This area up here is getting no sun, which means you would expect it to be very cold. But what we saw in the lab was that this hot water will move, and it moves up to Barrow, Alaska, and it takes some energy with it. Even though they don't get any energy directly from the sun, the water from the equator takes energy to them, which means their temperatures go up a little bit. And that's why Barrow, Alaska, even with no sunlight in the wintertime, can still be warm enough for people to survive. They are getting heat from the equator by convection, which is when water takes the energy from the sun and moves it somewhere else. And this is constantly happening on our planet because the water at the equator gets hot and it moves to the poles where it is cold. So here is a summary of that. Draw the arrow and describe hot water from the equator expands to the north and takes heat, which is energy, to areas near the Arctic Circle, which makes them warmer.